Lot,
Hi,
bless you. How are you?
I'm good. How are you?
Good. Is that the German flag behind you?
No, it's the Belgian flag.
It's the Belgian flag. Why would I say German?
I
Why would
don't
I do
know.
that?
Good
I'm so
question.
sorry.
Okay.
Okay, so I got a bunch of messages from mom,
Yes.
and I was on hold on a call, so I didn't see them. So,
Oh, it's not a problem. I was in a bio session. My mom thought that the hour had changed here because of daylight savings.
I see.
Um, but I just my teacher is recording the session. So
Okay, but then
all
she
good.
said we need to move the time from now on or something.
I think it just needs to be the same as usual. I don't know when
Okay.
daylight savings is. I can actually check. When is daylight savings? Daylight savings is the 27th of March, which is in
For you.
Yeah.
And so then we need to change then.
I think so. I think then we
Okay.
have to move to this time. But the time that we had before is ideal for me. So like in an hour.
At 1. My
Yeah.
time. Sorry.
Yeah. So 5
Okay.
p.m. for me, and then
Could we do, because I have someone locked in, although
Mhm.
she might want to move to, she's in France.
Okay.
I wonder if
Cool.
they change too.
Cool. They do. Everyone moves up.
So I wonder, okay, so I'll check with her. So you want to move to 1 p.m. my time, is that right?
Wait.
Eastern
Let me
time.
just
I'm
check.
not sure what time.
Yeah, I'm in Florida. Yeah, like how it's usually. Isn't that what it's usually like?
Mm-mm.
Oh, then maybe the hour did change. I don't know.
It changed for me.
Oh, okay. Yeah, that makes more sense. All right. Yes, that would be perfect if that worked out.
To 1 p.m. my time.
Yes.
Okay. Oh my, that's so dumb that I didn't realize it was my time change. Okay. Oh my gosh. Why did they change the time? Stop it already.
I actually love it. I love daylight savings.
I love that they changed the time, Lot. I just love it myself.
It's honestly, no, it's honestly great. You get an extra hour of daylight. It's just nice.
Well, okay, so stop it. Like, let's just leave it like this, is what I'm saying.
That's the governments have been talking about that.
The United States has been talking about it for years and nothing. Like, no. Like,
No,
I don't,
no.
okay, whatever. I don't, it was for farming. Well, no, it wasn't for farming. I read about it somewhere because that was the myth that it was for farming, and then it was, I don't know, it was for the war, and I don't know. I don't know. So,
So
what are we doing?
I have the entirety of section B of my mock exam. I got 0 points. So I figured maybe we could do that.
Okay. All right.
I can send you a picture of it.
Fantastic.
Oh wait, no, this is the wrong one. Wrong one. Ignore that email.
I will.
I'm gonna send.
Oh,
send
before we get too far in, I need to give a shout out to my brother Partha.
Oh yeah. Also, Felipe. Felipe wants one.
Oh, Felipe,
Yes.
you and Partha up to, I mean,
Yes.
no, you're not close to Lot, but
No,
who is?
of course not. Right. No, but
Felipe, Partha.
Felipe has started getting things right more often, and he always says it's Dave. He always says it's you. So it's helping.
Listen, they need to give mom a little bit of a stipend, right?
Yeah.
Mom is paying for them. What is that all about?
I know. It's honestly a scandal. Maybe they should give me some money.
That would be better. And don't tell mom.
No, exactly. Okay, I sent the correct one now.
Okay. How'd they do on the second part of the mock?
How what?
How did they do on the second part of the mock?
Oh, also very bad. But Partha did slightly better than I did, and I think Felipe was on the same page as I was.
I see.
Yeah. But I did better on paper 2 than Partha, so just make sure that that's known.
Well, I would expect nothing. I mean, we're talking Partha here, so.
Right.
Ooh.
Right.
No harm, Partha. No harm.
Full
We're
harm.
good.
Full harm, Partha.
Full harm.
I was Partha's assassin today, and I got him.
Good.
I got
You're
him out of
playing
our
a
little
game?
game. Yeah, it's like a week-long senior game for money. And I killed him in cold blood.
No wonder you guys aren't doing well.
Yeah, I threw a sock straight in his face.
Ooh.
Yeah.
Okay, hold on. I can't. Oh, there it is. I'm having difficulties here. Now let me open it. Okay. There we go. There we go. Ooh, I hate probability. I'm just telling you. I hate it.
Okay. I kind of like it, but I got 0 points, so I guess I don't like it that much.
Well, let's see. Let's get this. So your biology, like regular class biology or a tutor or what?
No, after school they've been doing like revision sessions.
I see.
Yeah, and I've been trying to go to them, but the teacher records them. So
Okay. All right, let's tackle this. Okay, so finally share. Share. Okay, finally.
you.
I thought you said you liked it.
I like the really simple ones. Like, what is the probability that so and so?
A biased four-sided die. So that's a
Yes.
pyramid. Yuck.
Mhm.
A is rolled. Let X be the score obtained when a die A is rolled. Okay, so this is the score, right?
Yes.
The probability distribution for all X is given in the following table, right? Find the value of P. Well, all of the probabilities must add up to who?
To 1.
Yeah. So 3.5P, 1, 2, 3 equals 1. Is this paper 1 or paper 2?
Paper 1. Where did 3.5 come from?
1P, 2P, 3P, 4P. So all of these have to add
Oh,
this. All of the probabilities of an event have to equal 1, right?
yes.
And
Yes.
so 3.5 is the yuck. So we're
Yeah.
going to go with a fraction. So, which I know you like much better.
Right.
So that's 7 halves.
Yeah.
P equals 1, which means, what are we going to do, Lot? What does P equal?
1 divided by 7 over 2. 1, 2 over 7. Huh? Oh, okay. Wait, why do you swap? Oh, okay. That's not bad. All right. Okay.
You can't be as bad as Americans with fractions. You can't.
No,
I won't allow it.
I've never known that.
Yeah, that's an algorithm. Or maybe this is easier for you. Okay, so 7 over 2P equals 1, right?
Right.
I can do anything I want to both sides of an equation, correct? As long
Yes.
as I do it to the same thing. How about we
Yes.
do this?
Yeah. So it
E
goes.
equals 1 times 2 over 7 or 2 over 7.
Yeah.
You multiply. It's the reason why we can do what we do here. What I just showed you. You multiply by the reciprocal,
Okay.
right? You're actually doing the same thing. Like if you had 2p equals 10, you wouldn't even think about it. You say, okay, p equals 5, right?
Right.
Because we
Yes.
divide both sides by 2.
Mm-hmm.
Dividing by 2 is the same as multiplying by 1/2, isn't it?
Yes.
So when you're dividing by 2, you're actually multiplying by the reciprocal of 2.
Yes.
Same thing.
Okay.
Okay.
Yeah.
Okay. So the expected value, I forget the formula. Give me 1 second. I thought I had the formula sheet up. Okay. Okay. Resources, IBAA. Oh, you're doing that girl casual hair thing. I'm hot type thing, right? You're too warm, and so you do the thing.
Yeah. Exactly.
My daughter's hair is too long. She can't. I don't think she. Yeah, no, she does it. Okay. We just want the thing. Equals the sum of x times the probability that x equals x. Oh. So the expected value, E of x, is equal to the possible points. So that's 1 plus 1 plus 2 plus 3 plus 4. Do you see where I'm getting that?
Yeah.
Right?
Yeah. And that's just, you just have to know to do that.
Well, times 2 out of 7,
Okay.
right?
Mm-hmm. So 10 times 2 over 7.
Yes. Which is 20 over
20.
7, which is 1 6/7. Nope, 6. Yes, 1 6/7.
Is it?
Yes. Two and 6/7.
Yeah.
I don't know why I put 1. Was that your issue?
Yeah. I was confused.
Sorry.
No worries.
Okay. And I don't know, here, let me put the formula up there for you. This is expected value. So there it is. And what that is saying is the expected value of the event X is equal to the sum of the outcomes, which are 1, 2, 3, and 4,
Mm-hmm.
times a probability that X equals X, which we found to be 2/7.
Okay. And that's what that sigma thing means? The
Sigma
sum of?
means sum.
Okay.
Sigma, let's see. This is this.
Okay.
This is that.
All right. That makes sense.
Okay.
Yeah.
All right. All right. I don't want that. That's Sarah's work. I want Lotte's work. So there's Lotte's work. Okay. Okay, so the possible values of R, again, these have to add up to 1, right?
Right.
So Q plus Q plus Q plus R has to equal 1, right?
Yeah.
So that means that 3Q plus R equals 1. So that would be R equals 1 over 3Q,
Yeah.
but that's not the range of values because Q, I was thinking this is the way to do it, but Q could be like infinitely small, right?
Yeah.
It could be 0.0000000001, whatever. We don't
Yeah.
know.
Yeah.
So it could be, I'm gonna say 0 less than R less than 1. So anything between 0 and 1, not including them.
Okay. That makes sense.
Okay.
Yeah.
This doesn't seem right though.
Let me see what. I don't know if he actually wrote the answers on it. But... Yeah, no, I don't know.
All right.
That does make sense though.
Huh?
It does make sense though.
Yeah, but then it doesn't make sense for R. So just let me check something real quick. Like I said, I hate the probability. All right. Okay. Okay. Well, you messed that up. Okay. Okay, I'm going to revise part B.
Okay.
I forgot one thing. It is the 1 plus the 2 plus the 3 plus the 4.
Mm-hmm.
9. Okay. You have to include the p's to account for the 1/2. I forgot about the 1/2. That's why I forgot this, and I'll explain that in a second. So let me get rid of this. Okay. So this is fine. Find the value of p. 3.5 p is equal to 1, and we got p equals 2/7, right?
Yeah.
Okay. Hence, find the value of e of x. Well, you have to take the value that you earn when you get this probability. So it's actually 1p plus 2p plus 3p plus 4 times 1/2 p, right?
Okay.
Okay. And that times the 2/7. Okay. So let me move that out of the way.
Wait,
I'll
I'm
just move it down
confused.
here.
Is that from a formula?
No, it's the same
That's-
formula,
Okay.
right? It's the 1p is here. Remember we did 1 plus 2 plus 3 plus 4?
Yeah.
Okay, so we have to do the product of that, right?
Yeah.
And then we multiply it by the value of p, right? The average, find the value of p.
Okay.
Okay. So what? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8p times 2 over 7, which is equal to, let's see, times 2, that's
16p.
16 over 7, which is 2 and 2/7.
What about p?
P goes away, like p you ignore 16/7 p or just 2 and 2/7.
But you can put p next to that if you want to.
Well, this all you need to get is the coefficient of the p. I should drop out the p right here.
Okay.
Okay, so it's just to the value, right? It's well, it is okay. Sorry. The
Okay.
p is still there, right? So the 2/7 is implied by the p.
Okay.
Okay, so you get the 8p, right? Which is 8 times 2/7, since p is 2/7,
Yeah.
which is 16 over 7. Sorry.
Okay. That makes sense.
Okay. Okay. So then, yeah, that's for B. Okay. So now for C, right? The range of possible values for R, right? So I was right the first time. I was thinking about it 2 different ways, right? So this would be CI. Let me do it here so it's a little clearer. Q plus Q plus Q plus R equals 1. 3Q plus R equals 1. R equals 1 minus 3Q, right?
Yeah.
And so Q, solving for Q. Oh, no, I need Q, right? No, R equals 1 minus 3Q, sorry. So then Q is 1 minus R over 3, right?
Right.
Over -3, which would be, if you can leave it like that, but we usually don't like a negative in the denominator. That's r plus 1, I'm sorry, r minus 1 over 3.
Okay.
Okay.
Yeah.
Okay, let me look at this next one real quick. Lot, I'm really sorry. Like I said, I hate
Okay.
probability.
No worries.
It's so confusing. So this is still
That's okay.
part of 1, right? Okay.
Okay.
So I now have that no, I'm not going to waste your time on this. I'm going to come back to this next time
Okay.
because it's been too long since I've done the probability and
Okay.
I thought I had it, but I don't. Okay.
Okay.
So Partha and who?
Felipe.
Felipe, I'm really sorry. So I only got one page. I only got this one, number 9. Is there more?
Not for this one, no, because I think he cut out some of section B because he felt like it. Oh wait, I've got another bit actually. The one that I sent you that was wrong.
Yes.
The first part of that, I think we can do, but the part that's crossed out, he said not to.
Oh, where he has X's through them?
Yeah.
So just do A and B.
Right.
Number 7 and A and B.
Yeah.
Okay. And this was part of the test?
Yeah.
Okay. F of x equals mx squared minus 2mx, blah, 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 blah. The line y equals mx minus 9 meets the graph of f at exactly 1 point. Okay. So whenever you have two equations that meet at exactly 1 point, you can set them equal to each other.
Okay.
To find that point, right?
Okay.
So we have mx squared minus 2mx has to be equal to mx minus 9. And that's where they will meet. Is that okay?
Yeah.
Okay. So if I subtract mx from both sides and I add 9, are you okay that we get mx squared minus 3mx plus 9 equals 0? Is that all right?
Yeah.
Okay.
Yeah.
So normally what we would do is we would factor this and then just find the solutions, right?
Right.
But we don't know what m is. That's what we're being asked to find. We can't factor it because we don't have any numbers.
Okay.
Okay. So then we have to go back to our good friend, the discriminant. Have we done the discriminant together yet?
No.
Okay. Does it ring a bell?
It rings a bell, but it's I have no idea what it is.
Now, I often wonder, where does ring a bell come from exactly? Where is that? What is the origin of that? Or
It's
maybe
like
you don't wonder such things and your mind is free
no.
of
I think
clutter, unlike mine.
I think it's like when you know when you have an idea and it goes bing. It's like that.
Yeah, but someone just did that?
Yeah,
like
I
when did
guess
that
so.
start?
I don't know. I'll look it up and I'll tell you on Thursday.
While I'm looking up the probability, you can look up that.
Okay.
Okay, so it is on your formula sheet.
Okay.
Okay, the discriminant, there she is. Okay, so this delta stands for D, stands for discriminant. That's just the shorthand. And off to the left, it does say discriminant. I just didn't put the words because all we need is a formula. In your formula book?
Yes.
Okay. All right. So do you notice anything, the relationship between the discriminant and the quadratic formula?
The b squared minus 4ac part is in both.
Yay. It's here, right?
Yeah.
Okay. So b squared under minus 4ac is under the square root, correct?
Right.
Okay. Now, b squared minus 4ac could turn out to be one of three possible things when you consider its sign, whether it's positive or negative, or it could be zero, which is neither positive or negative, correct?
Mm-hmm.
Okay, so if b squared, and IB loves this, it's like on the exam twice, some
Okay.
form of using the discriminant. B squared minus 4ac, if it's positive, it's greater than zero.
Okay.
So I'm going to write it like that, if that's okay.
Yep.
Positive. Okay. So do you see right in front of the square root, there's a plus and there's a minus, right?
Yeah.
Which means if we have a good square root, I'll explain that in a minute, I add something and divide by 2a, and then I subtract something and divide by 2a. So I get two solutions.
Right.
Right? And that's the same as like if I factored x squared plus 3x minus 4 equals 0. And I have x plus 4 times x minus 1 equals 0. I get two solutions, right?
Right.
A lot of times with quadratic, we're used to getting two solutions.
Yeah.
Okay. Sometimes we get one, don't we?
Yeah.
And sometimes there's no solutions, right?
Yeah.
Well, it's actually can all depend on the discriminant. Okay, because
Okay.
if I get something positive, the square root of a positive number, we can deal with that. Right?
Yeah.
Even if it's not
Yeah.
a perfect square, we get some nasty thing, but we still get two solutions. So that means there implies two solutions to the quadratic. Yes?
Yeah.
Okay. Now, if b squared minus 4ac is equal to 0, well, I have nothing to add or subtract, do I?
No.
Right? And the 0 is good because the square root of 0 is 0.
Yeah.
Okay. So that's a good guy. And that means there is one solution. Okay. And it's actually repeated.
Okay.
Why do I say repeated? Well, that's like x squared plus 14x plus 49 equals 0. That factors into x plus 7 times x plus 7 equals 0.
Okay.
X equals -7, x equals -7. It's the same solution, it's repeated, right? There's only one value of X, but it's repeated. So that's here we say repeated.
Mhm.
Okay, but I have to throw that in there because sometimes they'll throw that lingo in there. And so it gets confusing for whatever reason. And we also say two real solutions or one real repeated solutions, meaning a real number, meaning a number on the number line. Could be any number on the number line. Then we get the spoiler. B squared minus 4AC is negative.
Okay.
And it's the spoiler because we can't take the square root of a negative number in the real number system, right? The square root of -9.
Right.
Doesn't
There's no
work.
solutions.
It does work in the complex number system, which you don't have to deal with in this course.
I will never.
Well, don't say that. You might in university.
With pleasure, I will never.
I don't know. You might. Don't say it. Never say
Why
never.
would I? I'm not doing math.
Well, what are you doing?
I'm never touching math again. I'm doing politics, psychology, law, and economics.
You have to take some math in college.
No, that's in the US.
Oh,
I don't.
really? Oh,
Yeah.
lucky you. Okay.
Yeah, I know.
Okay, so there are no real solutions. There's complex solutions. I'm just going to say it. Okay. And I can't stand it that you don't have any idea what I'm talking about. So I'm just going to say that the square root of, or I squared, the square root of I equals -1.
Okay. Very
Okay.
nice.
So there you go. Okay.
I will remember that.
Thank you. Or I equals the square root of -1.
Okay.
So the square root of -9 equals the square root of 9 times the square root of -1, right?
Right.
Equals 3i
Okay.
in the
Yes.
complex number system.
I don't need that though, right?
You don't,
Okay. Yes.
but you've seen it. You've seen it. Okay.
Yeah.
So since we don't know these guys, and we know that there is they touch at exactly one point, that means there's only one solution.
Okay.
Right? So it could, it's a quadratic. What does that look like? I don't know. It could look like that, right? Just one point where they touch.
Right.
That's called a tangent line.
Okay.
Okay. Now, if they did this, that's two solutions.
Yes.
If they
So
did this,
we
that's no
know-
solutions.
We know it's a tangent line.
Yes, because that's the only way it can touch the curve in exactly one spot.
Okay.
Okay.
Yeah.
Not important for now, but it becomes very important in the calculus.
Okay.
Okay. So now I just need, do you agree that I need b squared minus 4ac to be equal to 0?
Yes.
Okay. And do you know your ABCs for the quadratic? They're right here for us if you don't.
Yeah,
right?
I do. Yeah.
Okay. So this would be -3m squared. Do you see where I got that?
Yes.
Tell me -4 times what?
4 times m times 9, so 9m.
Good. So then 9m squared minus 36m has to equal 0,
Mm-hmm.
right? So 9m, I can factor that out, times m minus 4 equals 0.
Mm-hmm.
So 9m equals 0 and m minus 4 equals 0.
Mm-hmm.
So m could be 0 or m could be 4, right?
But you can't put 0.
I'm sorry?
But 0 is not possible, right?
Correct. Because then we wouldn't have a quadratic.
Yeah.
Okay, so we throw that out, m equals 4.
Okay.
Okay.
Yes.
So That was a lot of real estate, so we'll move here. I guess I could make this smaller, couldn't I? Yeah, like that, this discriminant thing, it's going, like I said, it's gonna come up twice, and it's not immediately obvious when you first start,
Mhm.
but this equation, you're getting a solution to this equation, and you bring it all over and you see it's a quadratic, and you're like, I can't factor that, but I can tell the number of solutions.
But how do I know that I need to use the discriminant? Just when I can't factor it?
Well, because it says it meets at exactly 1 point.
Mhm.
So that's a clue, like, okay, there's one solution,
Mhm.
right? Well, how can I tell if there's one solution? Well, the discriminant tells me how many solutions
Right.
because of this stuff.
Yeah.
And hopefully the way that I've explained it, like if you forget this relationship, you just look at the square root and you think, oh yeah, positive would give me 2, 0 would give me 1, negative I hate. Actually, negative's kind of fun because there's no solutions and you're done.
Right. Great.
Okay.
Okay.
All right. Okay, so now B, the function f, so same function, can be expressed in the form blah, where P and Q are elements of R, find the value of P and find the value of Q. So now we know that f of x equals 4m squared minus 2 times 4 or 8. Is that okay? And I
Yeah.
shouldn't have said m squared. I should have said x squared because we replaced m with 4, right?
Mhm.
And that's it. That's f of x, and this is y, right?
Mhm.
Okay. Now it can be expressed in this form, right? So that means I have to factor it.
Yes.
Yes. P and Q are elements of the real numbers. So this I can factor out a 4.
Yeah.
4 times x squared minus 2x, right?
Yeah.
Which can be 4x minus 2.
Yeah.
So how in the world show that m equals 4? 4x squared minus 8mx. X squared minus 2x. Well, they're real numbers. So fine. So I guess we're gonna have to do it this way. I've never seen one like this. So 4 times, I'm gonna factor out just an x, and then I'm left with x minus 2. Is that okay?
Yeah.
Right? So we have to think of it as 4 times x minus 0 times x minus 2. Because they say it's in this form, right?
Right.
X minus something, x minus q. Now you don't have to write this if you don't want to, okay?
How does
But
that?
I'm sorry.
Wait, I just need to look at that for a sec. Hold on.
Okay.
Okay. I don't understand. I don't see where x minus 0, why that works. Oh, because of
Well,
the x.
yeah,
I see.
x minus
Yes.
0 is x,
Right.
right?
Yes, I see. Yeah.
So then do you see that P equals 0 and
Yeah.
Q equals 2?
Yeah.
Yeah. And it's not negative 2 because the form is minus Q.
Yeah.
You okay with that?
Yes.
Okay. So now so much fun with quadratics. C, the function can also be expressed in the form f of x equals 4 times x minus h squared plus k, blah, 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 blah. Okay, so do you recognize this form?
Vaguely, yes.
Okay, so y equals a times x minus h squared plus k is vertex form of a parabola
Okay.
where hk are the coordinates of the vertex. Right?
Mm-hmm.
Okay, so I'm going to rewrite what they want us to do. F of x equals 4 times x minus h squared plus k. So the only thing that is missing is the coordinates of the vertex.
Yeah.
Would you agree?
Yes.
Okay. So do you, there's so much to remember. Do you remember the equation for the axis of symmetry?
Something over 2a?
Yay!
B over
Right?
2a? B.
Negative b over 2a.
Yeah.
Okay, so now we're going to find the vertex. Here, I'll do it over here. It's going to be so much fun. The vertex, right?
Yeah.
So again, like, here's the deal. The axis of symmetry goes through the vertex of B, and this is x equals negative b over 2a, which means it's also the x coordinate of the vertex.
Right.
Right? So x of, let me see, my f of x equals 4x squared minus 8x. I have to go back to the original form to use this, right? So negative b over 2a, which would be negative negative 8, right?
Yeah.
Over 2 times 4, which would be 8 over 8. Hooray, it's 1.
Okay.
So now I have the vertex at 1 question mark, right?
We substitute the 1 into the equation.
You make me happy. And if I substitute it into the equation, what do I get?
-4?
Good. I'll just write it over here because I bet you Partha didn't get it.
I'll betcha.
I'm killing Partha. I don't even know him, but it's like I'm back in class because I always have to kill someone, right?
Right. There has to be a scapegoat.
There has to be.
Right.
Next up is Filippo.
Yeah.
Filippo or Filippo?
Oh, Filippo.
Okay. So it's f of x equals 4 times x minus 1, 4 times x minus 1 squared minus 4.
Yes.
From this. Whoop. Or I should say it plugs into here, actually. And this is, I'll say, HK as well.
Cool.
Okay. Okay. D for delightful. Hence, find the values of x where the graph of f is both negative and increasing.
Oh, okay.
Oh, where the graph of f is both negative and decreasing. You got a choice here. We can use the calculus, which we probably should do. No, we should graph it.
Okay.
It would be easier to graph. Calculus would involve a bunch, okay? So we know a couple of things, don't we?
Yes.
We know the
We just-
vertex is at 1, -4.
Yeah.
1, -4. We know that, right? And we also know that the y-intercept occurs when x equals 0,
Yeah.
right?
Which is
So,
isn't it -4?
yes, good. So that's all we need to know, because it is a happy parabola, meaning it looks like this, right?
Mm-hmm.
And if this is the vertex, then it has to go actually.
Wait, so if the y-intercept is -4, doesn't that mean it hits right next to the vertex?
Ooh, I thought it was, I put 0, -4, 1, -4. I was so excited because I just paid attention to the 0. Thank you. Let's do this. 4x squared. We did this right, didn't we? 4x squared
so.
minus 8x. Negative b is 8 over 2a. So that's 1. 4 times 1 is 1, minus 8 is 4. So that's 4 times x minus 1 squared minus 4. Okay, fine. So 4x squared minus 8x. Wait, 4 minus 4 is 0. Right? Okay,
What?
so if we let, oh my God. The two of us, we're terrible together. So if x equals 0, right?
Yeah.
This is 4 times -1 squared minus 4, right?
Oh, yes. Okay.
Equals 0.
Right.
So in my subliminal, okay, never mind. So we know it's coming down here, right? Oh, that's a terrible curve. So it's this beautiful curve, and it goes up through 2 actually, because it's the same distance from the axis of symmetry, right? So they want to know the range of values for which this function is both negative and decreasing. Can you see that from the graph?
Yes, I can.
What is
X
it?
equals 0 to x equals 1?
Yeah, so you want to put that in this form. 0 less than x less than 1, right? Because 0 is not negative, so it's not included. And 1 is where it changes from decreasing to increasing.
Yeah.
Good?
Yeah, good.
Okay. And then the last one. Get out of the way. We can get some of it in. Well, it's just A and B, so maybe all of it. I don't know. So y equals the natural log of x over x. So we have to take the derivative. Yes.
Why did, oh yeah, right, I see, yeah.
And
Doing the-
so
Oh, I
you
think I
remember
remember doing this.
the quotient rule?
Yeah. Can we move the x to the power of 4 up and make it negative, like the power?
We can, then we can use the product rule. It just means that we're going to have to do some algebra to make it look like this.
Okay, maybe show the quotient.
And that's why they kind of force you into it,
Mhm.
right? When they do this, because they want to see if you know the quotient rule,
Okay,
which is this one.
right, yes,
Okay. So it's VDU minus UDV, right?
yeah,
So like U equals ln x,
mhm,
du equals 1 over x,
right,
right? V equals x to the 4th.
yeah,
dv or d primed, I'm just doing the d because that's how they do it here, right? Equals 4x cubed.
yeah,
All good?
yeah,
So dy dx equals v x to the 4th du times 1 over x minus u, natural log of x, dv, 4x cubed, all over v squared, which is x to the 8th.
wait, so du over dx is the same thing as just du?
Yes, I was just shortening it. Sorry. dv dx.
Mhm.
That just means with respect to x. That's
Okay,
all. Okay. Sorry about that.
it's okay,
So this would be x cubed minus 4x cubed natural log of x over x to the 8th. Are you okay with that?
yes,
And I'm looking at my target. And I'm like, oh, I factor out an x cubed. I'm left with 1 minus 4 natural log of x
yeah,
over x to the 8th. And do you now see how this becomes x to the 5th?
yeah,
Equals 1 minus 4 ln x over x to the 5th.
okay,
Is that good?
yeah, cool,
Okay, so for part B, it says it has a horizontal tangent
okay,
at point P. Find the coordinates of P. Well, that means that dy dx,
it's
that
0,
happens when dy dx equals 0, because the derivative is the slope of the tangent, right?
mhm,
So then we get 1 minus 4 natural log of x over x to the 5th equals 0.
mhm,
Multiply both sides by x to the 5th. 1 minus 4 natural log of x equals 0.
yeah,
Negative 4 natural log of x equals negative 1. Natural log of x equals 1/4. Okay.
yeah,
Now I'm going to go, I can solve this going from logarithmic form to exponential, where e to the 1/4 power is equal to x, because this is, remember, this is a base e here.
mhm, okay,
Okay. So they didn't ask for the x coordinate, they asked for the coordinates, right?
right,
So it's e to the 1/4. And then I have to plug that into the original function, natural log of x over x to the 4th.
Mhm.
So that would be the natural log of e to the 1/4 over 1/4 to the 4th.
okay,
Okay. And anytime you have the same base as the base of the argument, in other words, I have an e here and an e here, it's just equal to this guy. It's equal to
Okay.
the exponent. Are you okay? Do you need to go?
No, it's okay.
Okay. 1/4 over 1/4 to the fourth.
Okay.
Fraction divided by a fraction. You
Okay.
multiply by the reciprocal.
Mhm.
Do you see how that's 4 cubed?
Mm,
4 to the fourth over 4 to the first.
oh, yeah.
And 4 cubed is 64.
Sorry.
Wow. Bless you. Oh, that's because you have the mic right here. It sounded extra funny.
Oh, great.
There was like a squeak, which was awesome. Partha and Filippo will agree because they'll. Oh, I don't know. I guess they have to be. I don't know. We'll see.
They hear me sneeze all the time.
Into the microphone?
No, just in person. It's just as bad.
All right. All right. I'll send this in the video to you later this
All right.
afternoon or evening
Perfect.
for you.
Great.
And we'll get the probability one on Thursday.
Okay, perfect.
All right. Bye.
All right. Thank you. Bye.